Alright guys, so the next thing we'll be looking at is the composition of stoichiometry. And this part of stoichiometry often confuses students, so you really want to pay attention to it. Now, 1 mole is equals to Avogadro's constant, which is 0.02 times 10 raised to the power 23. So 1 mole contains this guy. Now, for example, if we are given this equation or reaction plus O2 to give us 2H2O. Right. So if we are given 2H2, then oxygen to give us 2H2O. Now recall that anytime you see a number at the front of an element or a compound, that number is regarded as the number of mole. So if I ask you how many mole is contained in this element, hydrogen, it is 2 mole. Why is it 2 mole? Because 2 is at the front of the element. Now, firstly, we have to identify the number of moles this reaction contains. So hydrogen has 2 mole, oxygen has 1 mole, then water molecule has 2 mole. Now, recall that 1 mole is equals to Avogadro's constant, right? So hydrogen, which is 1 mole, supposed to contain 6.02 times 10 raised to the power 23. Oxygen contains 6.02 times 10 raised to the power 23. Then this guy is supposed to contain 6.02 times 10 raised to the power 23. Now, because of the number of molecules present, this guy contains 2 molecules. So this will now be 2 times the Avogadro's constant. This is 1 molecule, so it is 1 times, which is also the same thing as the Avogadro's constant. This is 2 molecules here, so this will now be 2 times the Avogadro's constant. Here are 2 questions for composition of stoichiometry. So the first one says, how many molecules? Molecule is the same thing as mole. How many molecules of oxygen are present in 8 grams of oxygen gas? Then B says, how many atoms of oxygen are present in 8 grams of oxygen gas as well? Now, my friends, I want you to remember what we've said during the introduction. We said whenever a number is at the front of an element or a compound is the number of mole or the number of molecules, right? Then whenever a number is acting as a subscript in an element, that number is the number of what? Atom. Okay. Now, for this first question, they are interested in the number of molecules, which is the number of mole that is present in 8 grams of this guy. Now, to solve this, remember, whenever mass is given, mass here is 8 grams. It is mass over molar mass. Now, what is the mass given? The mass given is 8 grams over oxygen. Oxygen is O2, diatomic, right? So it means it is oxygen plus oxygen. The value, which is 16 plus 16, is equals to 32. So this is 8 grams over 32. 8 grams over 32. So this is 8 over 32. This is 0.25 mole. Now, but they did not ask us the number of mole. They are asking us, okay, fine. This is not what they are asking us, but they wanted to know the composition in these compounds, right? So how do we go about it? Is recall another formula that says mole is equals to number of particles times 10 raised to the power 23. Now, power of mole. So this is to calculate the number of moles. We use mole is equals to number of moles over Avogadro's constant. Now, we just calculated this guy, the number of moles here, right? And O2 contains how many molecules? If for oxygen gas, how many molecules are here? Is 1, right? So this now becomes 0.25. Number of moles, we don't know, over 6.02 times 10 raised to the power 23. Now, if we cross multiply, right? If we cross multiply, so this becomes number of mole is equals to 0.25 times 6.0, 0.25 times 6.02. So this is 1.505 times 10 raised to the power 23. So let me quickly recap. These questions want to test our ability to identify mole and atomic number, or mole and number of atoms, right? Now, we say that whenever a number is at the front of an element, right, that number stands for number of what? Mole. Now, for this case, what is standing here is 1. What is standing here is 1. So we write it out as this. Okay. So moving forward, we've done A. Let's solve for B. Now B says we should calculate how many atoms, the number of atoms in the same 8 gram of oxygen. Now, the first thing we do, recall, whenever mass is given, it is mole is equals to mass over what? Molar mass. Now, in our last calculation, we already know that the mass is 8 over 30 or over 32, right? 16 plus 16. So if we do this, this is 0.25 mole, right? Now, before we go ahead to calculate, okay? Before we go ahead to calculate, now, this is oxygen gas. How many atoms is in oxygen gas? Of course, you can see the 2 clearly. So this will now be 0.25 times 2. What is this answer? I guess it's 0.5. So this is 0.5. Right? Now recall again, mole is equals to number of atom over Avogadro's what? Constant. Right? So what is our mole here? Our mole here is 0. Okay, our mole here is 0.5 equals to atomic number we don't know over Avogadro's constant, which if we cross multiply, number of atom is equals to 0.5 times 6.02. So this answer is 3.01 times 10 raised to the power 23. So